grab my pen here. Just basic full review up here at the top. Exponent is the little power that you see to the side. So if I just have 5 to the first power, what would that be? Just 5. Just 5, right? Done. That's it. That's all you gotta do. Anything to the first power is just going to give you back whatever it is. Like if I had 6 to the first, it would be 6. 7 to the first would be 7. So 5 to the first is 5. Okay, what if I do 1 to the 5th power? 1. Anything to any power is 1 to any power is 1, because you're just multiplying 1 by itself over and over again. Okay, now I'm going to see if anybody remembers this. Can anybody raise your hand? Do you know what you get if you do something to the 0 power? It's 1. It's actually equal to 1. Anything to the 0 power is 1. I'm going to actually go into that just a tiny bit more on the numbers that I have underneath here. But anything to the 0 power is equal to 1. And then the last one says 0 to the 5th. So if I did 0 to the 5th power, what would I get? Just 0. 0 times 0 times, it would just stay 0. Okay. Now I'm going to kind of start down the line on this a little bit farther to the right to try and explain a couple things. First of all, I'm going to try and explain negative exponent properties to you, and then I'm also going to explain why anything to the 0 power is 1. So let me just start kind of here. 4 to the first is just 4, right? 4 to the second, that means 4 times 4. So this is 16. 4 to the third, 4 times 4 times 4, this is 64. And 4 to the fourth, 4 times 4 times 4, 4 times, this is 256. Okay, so let me kind of explain really quickly. If you were to go backwards here, like backwards, I'm going to go from right to left. If I would take 256 and divide that by 4, that would be 64. If you take 64, divide that by 4, that will give you 16. If you take 16, divide that by 4, gives you 4. So it goes along like I'm going backwards if I divide by 4 each time. So if I do that, anytime I have something to the first power, if I work backward to the 0 power, this should be 4 divided by 4, which is why that is always 1. Because you're dividing as you go backwards when you look through this list. Now, the negative exponents, I'm going to write the property underneath here in a second for you. But if I keep following this pattern, this next one, I would divide 1 by 4. So this would be 1/4. And if I kept doing that, this would be 1/4 divided by 4, which is 1/16. And this would be 1/16 divided by 4, which would be 1/64. And you guys can see these numbers kind of match up, like 4 to the negative 2, there's a 16 here. 4 to the positive 2, that's positive 16. So negative exponent does not mean negative number, it means tiny fraction. So the bigger the exponent, the smaller the fraction is going to be when you go backwards, when you put it to the bottom. And I'm going to show you that rule in just a second, but that's where that comes from. Each time you're dividing by 4, so it makes it smaller going to the left. And each time you go to the right, you're multiplying by 4, it makes it get larger. Okay, so just in general, your little negative exponent rule, and I'm going to write 2 here because there's kind of 2 ways this can look. So let's say I have x to the negative n. X will just be my base as a little example. And if you ever have a negative exponent and you don't have a fraction, what you want to do is just turn it into a fraction real quick. And I just do that by writing it over 1. So this simplifies to be 1 over x to the n, and then that exponent becomes positive. I call it move it and lose it. So if you don't have a fraction, you got a negative exponent, make it into a fraction real quick, and then you're just going to move it to the bottom, lose the negative on the exponent. It's not a negative number, it is a fraction. Okay, now the other way this can look, like let's say I had 1 over, and I'll just use a different letter, x to the negative m. If you have a fraction with a negative exponent in the bottom, you just go the other direction. Still going to be move it and lose it. We're just going to move it to the opposite part of the fraction. So it would actually come to the top there. So that would be x to the positive m. So kind of 2 different ways that can look depending on how the problem's presented to you. So I just have a couple practice problems real quick. So if you got a negative exponent, it's not considered simplified if you got a negative exponent. So 7 to the negative 2, I'm just going to turn this into a fraction real quick by writing it over 1. And then all you got to do, move it and lose it. Move this to the bottom of the fraction, lose the negative on the exponent. What you're going to do is leave a 1 on the top, because it exists, so not canceling it out. And then that's 7 to the negative 2. When I go to the bottom, it's 7 to the positive 2. And then if you can, like this is a number here, I can just simplify this real quick. This would be 7 squared is what, 49? So 1/49th would be what I get if I simplify that. Similar, but I got a negative exponent in the bottom in my other example here. This just moves this to the top, and it really gets rid of the fraction. When you move it, you lose the negative on the exponent, so this would be 5 to the positive third power, which is just 5 times 5 times 5, which, of course, if you guys want to use your calculator, you can, but that should be 125 if you simplify that. Bless you. Is anybody having a question? Okay, all these are kind of, hopefully review. They're kind of quick properties, but I want to make sure you guys remember them. All right, so the product rule. So if I have a product rule, I'm going to multiply like basis. So let's say I have x to the n, and I'm going to multiply that by x to the m, so 2 different powers. Like basis, meaning they're both an x to an exponent. What does anybody, just raise your hand, does anybody remember what you do with the exponents in that situation? Somebody just said it. You add them, yes, okay. So this would be x to the n plus m. So multiply like bases, they're both an x, you're going to add the exponents together. Okay, so if I just follow that, right? I have x to the third times x to the fifth. I literally just take 3 plus 5, and this would be x to the 8th. Now, absolutely, you don't have to write this, but I just want to show you this real quick. So x to the third, what that means is you would multiply x by itself 3 times, right? And x to the fifth, I would multiply x by itself 5 times. So if I'm multiplying that all together, you see that's a total, there's 8 x's that I just wrote down there. That's where that property comes from. You don't have to write that out. I'm just trying to show you where it comes from. So just add your exponents if you're multiplying like basis. Okay, now, this one I put on here on purpose because people always mess this up. So they're good usually with variables, but if I start to involve a number, people get messed up for some reason. Okay, so this is 2 to the 8th times 2 to the 6th. Now, don't write 4. I'm sure someone was really tempted to write 4. Don't multiply those numbers, okay? This is going to stay 2. Because I would have literally, for that first part, I'd have 8 2's written out, and then I'd have 6 more 2's written out. So it's still going to be a base of 2, so make sure you leave that, and then you go ahead and add your exponents. So this would be 2 to the 14th. If you get some, like 2 to some huge power, just leave it in that exponential form. That's totally fine. If you had like 2 to the 5th, you could do that on your calculator pretty quick. But that'll be 2 to the 14th. Don't multiply the numbers. I don't know why, but sometimes people get really tripped up by that. So if it's a number base, as long as they're the same, they're both 2s, you just add the exponents just like you would do with a variable. All right. Now, quotient, product is multiply, quotient is divide. So quotient rule would look something like this. X to the n over x to the m. So I'm going to divide like bases here. Can anybody raise your hand, tell me what do you do with the exponents in that situation? Subtract, yes. If you multiply, you're going to add. If you're dividing, you're going to subtract. Okay, so this would be n minus m. Okay, now, I don't actually use that property very often, and I will just ask you the question that I asked to do these problems. You can use that property if you want to subtract the exponents, but I'm just going to ask you in a little different way when we actually look at the problems. So I have like bases. They're both an x to a power, so I have x to the 5th over x to the 3rd. Okay, so here's what I usually say to people. Where do I have more x's, the top or the bottom? Top, how many more? 2, so this is x squared. And that's it. If you did 5 minus 3, you would get 2. That's just how I asked myself that question. What's really going on there, and you don't have to write this down if you don't want to, you have 5 x's over 3 x's. So 3 in the bottom cancel 3 in the top, and you still have 2 left over in the top, but that's the basic concept behind it. You don't have to write that out. All right, now, if I look at the other one, I've got x to the 4th over x to the 7th. If I asked you that same question, Where do I have more x's, the top or the bottom? What would you tell me for x to the 4th over x to the 7th? Bottom. How many more? 3 more. All right, so you can't just leave the top with nothing. So it exists, so just leave a 1 on the top. You have 3 more in the bottom, so you'd have x to the 3rd. Now, if you actually wanted to apply the rule there, this would be 4 minus 7, which would give you x to the negative 3rd, which we would get rid of that negative exponent using that property. But if they just ask you that in that format, I usually find that people think that's a little bit easier to do. All right. Power rule is the next one. Sorry, there's a bunch of different rules. We're almost done. There's just a couple more. All right, so the power rule, let's say I have x to the n, and then that's in parentheses. And then I have another power outside of the parentheses. So it's a power to a power. What do you do with the exponents in that rule? Does anybody remember? You multiply them, for sure. All right, so this is the xn times n. To simplify that, get rid of those parentheses. All right, so power to power, you're just going to multiply the exponents. If you look at the very bottom of the page here, n squared to the 4th, you literally just do 2 times 4. So this would be n to the 8th. Now, again, you don't have to write this down, but I'm just going to show you real quick. N squared to the 4th means I would have n squared written 4 times, all multiplied together. And then each n squared would just be n times n. And again, you don't have to write this out, but there would be a total of 8. It's a little faster to just apply that property and go ahead and take 2 times 4. You don't have to write all that out, but that's where that comes from. Now, if you have a negative exponent, I would go ahead, just do your power to a power. I'm going to multiply the exponents here. This would give me n to the negative 10th, so just 5 times negative 2. Now, if that's the case, just remember it's not considered simplified if you have a negative exponent. So if you don't have a fraction, I'm just going to turn it into a fraction real quick by writing it over 1. And I'm going to do the same thing we were doing up at the top, just move it and lose it. This would be 1 over n to the positive 10th. Move it, lose the negative on that exponent. It's in the top of a fraction, you move it to the bottom. If you got a negative exponent in the bottom, you move it to the top. Does anybody have any question? Okay. Yeah, I got kind of 2 more. They kind of go together at the top of the page, and then I just have I have some practice with those, and then I just have some random practice at the bottom just to go through all the different properties with you guys. Okay, product to a power. So product means I'm multiplying something together. You could have like 3, 4, or 5 things. I'm just going to write 2 for my basic property, what this looks like. So what I'm going to write for my product is I'm going to say it's a times b to the n. All right, no adding or subtracting. These are literally just things being multiplied together. This works almost like a distributive property. What you're going to do is you're going to give that exponent to anything that's in the product. So to get rid of those parentheses there, this would be a to the n times b to the n. And it could be you have to apply the property we just talked about, power to a power. You'll see that in some of my examples. But you have to give that exponent to everything inside the parentheses where you have your product. The quotient rule, quotient means division, and this is going to look really similar. It's just going to be a fraction instead of multiplying. So let's say I had a over b in some parentheses, and then I had an exponent on the outside of that. Everybody inside the parentheses gets that exponent. So a gets the exponent, b gets the exponent. If I were to simplify that, a to the n over b to the n. Does anybody have any questions so far? That's not too bad. All right, now, here's the deal. We're just going to practice. This is either a product or a quotient to a power for each one of these questions in example 5. So sometimes people will forget to do this. This is 2 times a to the 7th. That's your product. So when I give out this exponent, the 2 needs that as an exponent, and then also the a to the 7th. All right, so if you want to skip any of these steps that I'm writing, you go right for it, but I'm just going to write it out real quick. So this is 2 to the 5th. That 2 gets that exponent. Now, this is the little review from the very bottom of the front, power to a power. If I do a to the 7th to the 5th, power to a power, I'm going to multiply those exponents. So that would be 5 times 7 is 35, so a to the 35th. And then you guys can simplify if it's not like a crazy exponent like 2 to the 5th. This is just 32 if you want to use your calculator to simplify that a little bit. 2 to the 5th power is 32, and then nothing more I can do there. All right, the next one is a quotient because I'm dividing two things, and everybody inside the quotient gets that exponent of 3. So on the top, you have 10 to the 3rd, and then on the bottom, x to the 9th to the 3rd, that's going to be a power to a power, that bottom property we had on the front. So I'm going to do 9 times 3, which is 27. The only other thing I would do there real quick, 10 to the 3rd power, you can actually do that. 10 times 10 is 100, times 10 again is 1,000. So the top of that would simplify to be 1,000. Is anybody having a question at all so far? The next one I have is a product, but it's got 3 different things. So it's got a 6, x to the negative 5th, y to the 4th. So everybody in here needs this 3rd power. So I'd have 6 to the 3rd. Now, power to a power, we're going to multiply the exponents. I'm just going to go ahead and leave the negative right there. So negative 5 times 3 would be negative 15. We can simplify that negative exponent in a second. Y to the 4th to the 3rd, 4 times 3 is going to give you 12. And just real quick, if you guys don't know this, 6 to the 3rd power is 216. So I'm just going to simplify this just a little bit at a time. Now, it's not considered simplified if I see that negative exponent there. So I just want to turn this guy into a fraction real quick. And what we're going to do, you only want to move if you have a negative exponent. So I've got a negative 15 exponent on the x. So just going to move that term to the bottom of the fraction. Everything else is going to stay on the top. So we're going to keep the 216 where it's at, the y to the 12th where it's at, and then I'm going to move it and lose it. So I'm going to lose the negative on that exponent. I'd have x to the 15th on the bottom here. Does anybody have any questions? All right. Now, the last one here, I had a bunch of stuff going on because I've got products and quotients in that same problem. I got negative exponents. I got all kinds of stuff. What I might recommend, if you can, if inside the parentheses, if you think you could simplify that maybe a little bit before you start the problem, I would maybe recommend doing that before you put the exponent out to everybody in there because it might save you some time. So could I simplify just inside the parentheses there? Just raise your hand and tell me, could you simplify that in any way maybe before we use that squared on the outside? 8 squared is 64. You want to go ahead and just, we could do that too. We can just go ahead. So this would be 64. What would you have for your exponent on your x? Sweet. All right. What would you have on the bottom? 16. And then, perfect. Okay. Now, we're good. So I'm going to grab my calculator. I'm pretty sure if I divide 64 by 16, I think it's just 4. Yes. Okay, so where would I put the 4 in the fraction, the top or the bottom? If 64 over 16 divides and gives me 4, would you put the 4 in the top or the bottom? The top, right? The bigger number's on the top. 64 is on the top. So we're going to leave 4 on the top. I would leave the x alone. So x to the 6th, they're different letters. What would you do with the y? You got to move it up because you don't have a simplified expression if you got a negative exponent. Now, if you just move it up, it's just multiplied when you move it up, or if you move it down, depending on the question. If you're moving a negative exponent, it just gets multiplied by everything. And then that actually would cancel the fraction completely out there. That negative is all I'm moving. The 16 was canceled out by us dividing 64 by 16. So I actually don't have a fraction anymore. There is my answer. Good. Okay, anybody have any questions? All right, now, the bottom is a complete mix of all the different properties that we've talked about today, just to see if you guys are understanding this. Okay, so let's just start with the very first. I have some different variables in here. So I've got 5p squared times q, and I want to multiply that by 2p squared times q to the 9th. Okay, buddy, tell me what you would do to simplify that one. Just raise your hand and tell me. What do we think? Monday morning, after winter break, everybody's asleep. Go ahead. We don't need to distribute. Okay, how would you combine it? Okay, so what would you write for that? Perfect. Okay, so 5, just multiply your number. So just 5 times 2, p squared times p squared. Now, I know this is tricky. I'm not multiplying, we're adding those exponents. I know 2 times 2 and 2 plus 2 are the same thing, so that's a little tricky. How many q's should I have in my answer? I've got 1 in the first set of parentheses and 9 in the second set, so how many total? 10. There's 10. I know this is super tricky. So I have q to the first, so there's 1 there, 9 more here, so you'd actually have q to the 10th. So don't forget that. If you just have a plain variable, it doesn't have an exponent, they're not going to write the 1 in there in most cases, but you do have 1, so I would have 10 total in terms of my exponents. Okay, now this question's super weird. Just multiplying my numbers, right? -4 times -2 is 8. What would you get if you multiplied x squared times x to the -2? You get 0. Yes. Okay. So if you put those together, you'd get x to the 0, which is equal to what? Anything to the 0 power is 1. Perfect. Now, here's the deal. You would still have 8 as your answer, and then x to the 0, it would literally just be like 8 times 1. So the answer to that question, I know that's super weird, but it's just 8. For number 3, I got a couple things going on here. So I've got an x to the 5th, and then what I got to do here, I've got a product to a power. I got to distribute that exponent. So that 2 needs a 4th power, and then that x needs a 4th power. Now, 2 to the 4th, and you guys are welcome, just do it on your calculator if you're not sure what it is. 2 times 2, 4 times, you're going to get 16. How many x's do I have there? 9. 5 here, 4 here, so x to the 9th. That's my answer, all done. All right. Let me have, for number 4, I'm just going to ask you, where do you have more A's, the top or the bottom? How many more? 12 more, right, there's 2 on the top, 14 on the bottom, so there's 12 more on the bottom. So A to the 12th, I'll get rid of the A's. Now, what is 8 over 32, what is that going to reduce to? 4. Would the 4 go on the top or the bottom? Bottom, the bigger numbers on the bottom. Now, you can't just leave nothing in the top because it exists. So if everything cancels out of the top, we're just going to leave a 1 up there. Now, the reason we're getting this, 8 over 32 just reduces to 1/4. That's what I'm doing there, is just reducing those numbers. Okay, on number 5, what I would tell you to do, because you got the top in parentheses there, I would go ahead and do everything in there to the exponent and then go ahead and simplify when you're done. So 12 squared, you can get 144. And then for the exponents, I'm just going to multiply. So x 2 times 2 is 4, y 3 times 2 is 6. Okay, the bottom, I didn't do anything with that. Now, I'm going to cheat and grab my calculator here real quick. Let's see what 144 divided by 8 is and see if that's a nice number. It is. It's 18. Okay, let me scooch this up so I can actually see it. Now, bigger numbers on the top, so I'm going to leave the 18 on the top. Okay, now, where do I have more x's, top or the bottom? Trick question, they're the same, right? So so they don't become 0, they cancel each other out. That would become 1, be x to the 0, which would be 1. Okay, where do you have more y's, the top or the bottom? How many more? Just one more, so this would simplify. You would just have 1 y left on the bottom, so 18 over y would be the answer there. Okay, this next one is super weird. What I would recommend on this, and you can do this in different ways, if you want to distribute the exponent or if you want to simplify first, is completely up to you. What I might do, since that exponent is -8, I'm going to just kind of simplify the inside of this real quick. The very top of that, you would just have, we'd have to move the x to the -2, and we have to move the x to the -5. So if I just get rid of my exponents being negative, the x to the -5 and the x to the -2, those guys would just switch places, and we'd lose the negative on the exponent. And then what I might do, again, before I apply that exponent of the -8, I would just simplify this a little bit. I'd have x to the 9th over x squared. And then all simplified there, I could do that real quick. I got 7 more x's on the top. And then I would go ahead and apply that exponent on the outside. That's just how I would do it. There's different ways you could do that problem and still get the same answer I'm going to get here. But I just simplified it all down the best I could on the inside of the parentheses. Now, when I actually do this, we end up x to the -56, which is not considered simplified, right? So just turn it into a fraction real quick, move it and lose it. So my actual answer there would be 1 over x to the 56 power. Does anybody have a question? Okay. Got a couple more here. Almost done. A couple of these, just little tricks I want to show you real quick. For number 7, it says we've got 3, and then x to the -3, y to the -2, all that to the -2. Now, what I would do here, everybody, including that 3, gets that -2 exponent. That's your product to a power here. So this would be 3 to the -2. Now, for the power to a power, we're going to multiply the exponent. So for here, negative times negative is actually going to become positive. So -3 times -2 give you x to the 6th. -2 times -2 gives you y to the 4th. Now, I do still have a negative exponent here, so that's not considered simplified. So I'm just going to take just only the negative exponent, just move that down to the opposite part of the fraction. X to the 6th, y to the 4th. I can't do anything more there because those are different letters, so we can't simplify that. That 3 squared is going to move to the bottom, and I'm going to write that as 9. All right, so just real quick, 3 squared equals 9. That's where I'm getting the 9 from, just kind of simplifying as I go a little bit. All right. Now, for number 8, I want to show you a little trick on the calculator in 1 second with the numbers, but let me just move the negative exponents. So the y to the -6 would go to the bottom. The x to the 1st would go to the top. Completely, if you want to, skip writing out this step. But this would be x to the 7th, and then x to the +1 would go on the top. This would be 60, y to the 4th, and then y to the -6, when I move that to the bottom, that would become positive. When you move it to the opposite part of the fraction, it's being multiplied, so that's going to be the product property here. So on the top, I'd have 18. This would be x to the 8th, because I've got 7 and then 1 more. And then on the bottom, we'd have 60 y to the 10th. Okay, now let me just show you a little trick really quick if you don't know this already. So if you have a scientific calculator, it'll do this too, but on the graphing calculator, it's my favorite button. So I'm super lazy about reducing fractions, which is probably not good to admit, but whatever. All right, so I'm going to take 18 divided by 60. I look at that and I know that's got to reduce because those are both at least divisible by 2. So your calculator can reduce this for you. What you just do, just type in what you're doing, like 18 divided by 60, hit enter, so you can have a decimal, and you might be able to convert it from there. But I'm just going to show you this real quick. There's a button, it's the 4th one down, it says math. If you hit that, it brings up this big, nasty, complicated looking menu, but I really just want the very first thing that says FRAC, which will convert it to a fraction. Just hit math, and then hit enter twice, and it'll give you that fraction in lowest terms. Sorry, it's not real clear on the screen there, but it should be 3/10. And so you can feel free to use that button. So this would be 3x to the 8th over 10y to the 10th. So I'm just using the calculator to kind of get my fraction reduced for me real quick. So just type in the fraction you want to do, hit enter, and then just hit the math button, hit enter twice. It'll give you the fraction in lowest terms. Okay, now I have one more here. The reason I put this on here, this starts to confuse people when we're working with the negative exponents. I have a -15, just -15. That's not a negative exponent, it's just a negative number. So you don't move that, all right? So the only thing I would move here, I would move this b to the -2, that would go to the bottom. But the negative 15 is going to stay on the top. So this would be negative 15, a to the 6th, 3, it'd be a to the 4th, b to the 5th, and then b to the positive 2 would go to the bottom. If you want to simplify as you go, that's fine. I'm just trying to write out where this is going to come from. So to simplify the numbers, what would you get if you just did like negative 15 divided by 3? Negative 5. Now, I'm going to leave a negative 5 on the top, right? The 15's on the top, so the negative 5 is going to stay on the top. Okay, where do I have more a's, the top or the bottom? How many more? All right, so we're going to have a squared on the top. And then on the bottom, I had b to the 5th and b squared together. If we put those together, you're just going to add the exponents. So it'd be negative 5 on the top with an a squared, b to the 7th on the bottom. You do not move negative numbers, you just move negative exponents. So go ahead and leave that negative 5 on the top. Okay, is anybody having a question? Okay, so all I've got for you guys